Okay, hello everyone. We are going to start our unit on solution chemistry by talking about aqueous systems. Of course, this comes from chapter 12 in your book. All right, so we're going to talk about solutions. A solution is a mixture of two things where one thing is dissolved in the other thing. And if that sounds kind of vague, it's deliberately so. And I hope that the reason for my vagueness will become clear as we go through. So let's talk about some vocabulary terms first on how we talk about the situation where things are dissolved in one another. There's the process of solvation, not salvation, but solvation. And this is the process of one substance dissolving into another substance. For example, if you sprinkle some or you pour some sugar into your tea, the sugar dissolves, so the sugar dissolves in the tea. That's a process of solvation. All right, we have some terminology to refer to the sugar and the tea. So the word solute, it refers to the dissolved particle, which in that example that I just gave you would be the sugar. Sugar is a solute, and it is dissolved in the solvent, which in my example is the tea. That's the dissolving medium. Another way to think about it is the solute is the stuff that gets dissolved, and the solvent is the stuff that does the dissolving. I don't know which way to remember it is better for you, but the sugar in the tea or the way I just stated it, but you want to know the difference between a solute and a solvent. Okay, so we can classify solutions in a couple of different ways. One of those ways is to talk about polar versus non-polar solvents. So you can have a polar solvent where the dissolver, the thing that does the dissolving, the solvent, is a polar compound. And polar solvents are good at dissolving polar compounds. So you've got for example, a polar compound might be an ionic compound, and a polar solvent might be water. So water is a polar compound, and it's good at dissolving other polar compounds like salt. So you put some salt in some water, and the salt dissolves. You made a polar solution. You don't really usually say it that way, but we put a polar solvent in dissolving a polar solute. So that would be an example. We did this in our lab earlier today when we dissolved copper 2 chloride in water. Copper 2 chloride is an ionic compound, and water is a polar solvent. So we made an example of this earlier today. There are also nonpolar solvents. So this is where the solvent itself is a nonpolar compound, and those kinds of compounds are good at dissolving other nonpolar compounds. So an example of that may be a fat or a lipid. So you know that, for example, lipids or fats like butter don't dissolve well in polar compounds like water, right? Fat and water don't mix. Oil and water don't mix. But fats or lipids oil can dissolve other nonpolar compounds. So a lipid can be dissolved in oil, for example. I have some other examples on the next two slides. All right, so our water molecule is shown here. We've seen this diagram before. H2O, our favorite example of a polar compound, and that's because the oxygen here carries a small partial negative charge on it because it's an electron hog, and it's pulling away the electrons from hydrogen that are attached here and here. So the hydrogens have a small positive charge on them. You've seen this before. This is the kind of the poster child for polar. So water molecule has a net polarity. That means it's going to be a polar solvent, and these small positive and negative charges help to make bonds between water molecules. You might remember that from when we talked about intermolecular forces a couple of units back. All right. These small positive and negative charges on the water molecule are also helpful at dissolving the ionic compounds that water is good at dissolving. Water is a polar solvent. It's good at dissolving polar compounds like ionic compounds. Benzene, this molecule here, is a nonpolar solvent. So there's no small positive or small negative charges here. This is completely nonpolar. This molecule, benzene, because there's no atom in this molecule that is pulling electrons away from another atom in the molecule. And so there's no small positive and negative charges. It means there's no polarity. This is a nonpolar solvent. It has a very low degree of intermolecular forces. In other words, there's not much attaching this benzene molecule to the one right next door, which is very different from with water. Remember, one water molecule is strongly attracted to the next water molecule. Not the case here. And of course, a nonpolar solvent is good at dissolving nonpolar compounds like lipids and fats and so on, long chain hydrocarbons. Okay, so let's move on to some other definitions. So an electrolyte. There we go. Electrolytes are compounds that conduct electricity when you put them into aqueous solution. Now let's stop for a minute just to make sure everybody remembers. Aqueous means water, basically. So an aqueous solution is a water-based solution, one in which water is the solvent or the main solvent. All right, so you don't get a lot of electricity conduction in a nonpolar solvent because nonpolar solvents are not good at dissolving electrolytes. We'll see why in a sec. So a compound that is good at conducting electricity when you dissolve it is called an electrolyte. There can be weak electrolytes and strong electrolytes, just like there were weak acids and strong acids. See the connection? Okay, for a weak electrolyte, only a small fraction of the solute actually dissolves in solution, and that gives you weak electrical conduction. An example of this would be a weak acid like acetic acid. So just to make sure we understand this part, to conduct electricity, in order for electricity to be conducted through a solution like we're talking about here, there have to be positive and negative ions available in the solution. You don't ever have that with a non-polar solvent because they don't dissolve polar compounds to give ions. So non-polar solvents aren't good conductors of electricity because they don't dissolve things and produce electrolytes, small positive and negative charges floating around in the solution. All right. Strong electrolytes, not surprisingly, is where most or all of the solute dissolves in the solvent. You get very strong electrical conduction, and examples of this are strong acids like HCl. All right, so this connects back to our acid and base unit that we did a little bit ago. Hopefully you remember that. Strong and weak acids are kind of similar to strong and weak electrolytes. Okay, so just here, one of the things that we did in our limiting reagent lab today was to dissolve some copper 2 chloride in water. But if you remember, the actual formula of the substance that you weighed out today was CuCl2 dot 2H2O. Remember that? So that meant that there were two water molecules associated with each CuCl2 in that dry powder, bluish powder that you weighed out today. The two water molecules in that formula are known as water of hydration, and that just means that there's that there is water in that crystal, in that ionic crystal. And we refer to compounds that let this happen as hydrates. They are compounds that contain water in their crystal structure, like the one we saw today, copper 2 chloride dot 2H2O. Here's another example, magnesium sulfate dot 7H2O. This is also called magnesium sulfate septahydrate, 7 waters. And so some types of ionic compounds will have water sort of inserted into the crystal, intercalated into the crystal structure, and that means that they'll have a formula that looks like this, where there's the formula of the compound and then a certain number of water molecules associated with it. These water molecules are called water of hydration. You can drive off that water if you want to by heating up the compound and kind of drying it out. So in the past, we've been able to do a lab where we took a hydrate like this and we drove the water off using heat, and then we're able to do some lab activity there. But we didn't get to do that this time. So just so to explain, that this is what water of hydration means. It's the water that's associated with the crystal structure of certain ionic compounds. Okay, let's circle back and talk. So we talked about solvents, the things that do the dissolving, and solutes, which are the things that get dissolved. Okay, and so far we've talked about situations where the solute literally dissolves into the solvent and makes a solution. There are other situations where one thing is dissolved in another that isn't quite as straightforward as a simple solution. One example, and there are, why does it keep doing that? One example is a suspension. All right, a suspension is a mixture of a solute in a solvent, but the particles of solute settle out over time. All right, so if you like shake the solution, all the solute particles swirl around and look like they're dissolved. But if you let this suspension sit on the countertop, the particles settle out to the bottom of the beaker. So that's actually what we were seeing in our lab that we did today. As the reaction proceeded, copper was formed and it settled to the bottom of the beaker. That's the particles were settling out over time. So that was a suspension. So that's one example of a suspension that we saw in class today. Other examples are things like clay in water or muddy water. That's a suspension. A snow globe is an example of a suspension where the particles that are dissolved get dissolved, that will settle out over time. All right. And so let's move on. Another kind of situation like this is called a colloid. Colloids. So here the particles, the solute particles, are evenly distributed in the solvent and they don't settle out over time. All right? So some examples of colloids are things like jello or glue, where there are particles distributed in a solvent and they don't settle out over time. Paint is an example of a colloid. Smoke is an example of a colloid. And the main reason I want to make sure to include this one is we're kind of talking about like these things are always liquids, but one gas can be dissolved in another. Smoke is an example of where there's one gas dissolved in another gas, and it makes a colloid, and that's what smoke is. All right, so don't limit your thinking to just um, solids dissolved in liquids. You can have gases dissolved in liquids, and you can have gases dissolved in other gases. All are possible. The third and final thing that I wanted to talk about today are called emulsions. That's a word that you might even have come across before, I don't know. This is where a specific version or a specific type of colloid where you've got a liquid dispersed in a liquid. And remember, with a colloid, the particles are evenly distributed and don't settle out over time. So a colloid of a liquid in a liquid, some examples are salad dressing, especially things like ranch dressing. There's an example of an emulsion. Mayonnaise is an example of an emulsion. Moisturizers, like you put on your hands when they're dry, those are emulsions as well, where there's a liquid dissolved in another liquid and the particles do not settle out over time. That is an example of an emulsion. All right, and that is it for today. We will pick this up again on our next video lecture to come tomorrow. Thank you.